Machine learning, polynomial regression. Okay, if you found a bad fit, okay, in the previous video, I chose you the bad fit. Okay, if your data points clearly will not fit a linear regression, it might be ideal for some other techniques like a polynomial regression. If you still want to use regressions to solve the problems, linear regression is not a good choice. You have to find some other techniques and just try polynomial regression. Okay, polynomial regression is similar to linear regression, and it uses the relationship between the variable x and y, okay, to find the best way, okay, and draw a line through the data point. Okay, how does this work? Python has methods for finding a relationship between data points and to draw a line of polynomial regression. Okay, how to use this method instead of going through the mathematical formula. Mathematical formula sometimes is difficult. Okay, for linear regression is, you know, just a simple mathematical formula like linear regression, okay, right? Y is equal to mx plus c, right? M is slope, x is independent variable, and plus c is y-intercept. Very basic. So you can compute it manually because you are going to study the relationships between just two variables. But for a polynomial regression, the mathematical formula is a bit complex. So it is difficult to compute it manually. So look at this example. Okay, we have registered 18 cars as they were passing a certain toll booth, and we have registered car speed and the time of days, hour, okay, starting from 1 a.m., right? 2, 3, 4, 5, 6 a.m. Okay, and the passing occurs. The x-axis represents the hours of the day and the y-axis represents the speed. Okay, this is 1 o'clock, 2 a.m., 3 a.m. until 22 p.m., 10 p.m. Okay, 100, okay, the average speed at the first hour, okay, 100, and so on. Okay, when you plot it, okay, plot scatter, okay, shows, okay, this scatter plot, you see, all right, and then we import numpy and matplotlib library to draw the line of polynomial regression. So let's have a look. You import numpy and then import matplotlib library, right? Create the arrays, okay, that represent the values x and y, and then numpy has a method that let us make a polynomial model. So it's to call better to call numpy, okay, dot function polynomial, okay, poly1D, okay, polynomial one dimension, okay, and in this function you need to call numpy one more time, numpy dot polyfit, okay. Don't remember, you can just observe like what I mentioned. Okay, you call the function polyfit. Okay, you need to enter 3 data. Okay, x, y, and 3 values. Okay, when 3 is the degree of the fitting polynomial. Okay, just try the number. Okay, don't focus more on the concept of degree of fitting polynomial. Just try the number first. Okay, and then specify how the line will display. Okay, we start at the position 1 and with position 22. Okay, you call numpy, okay, and line space, little space, this line space. Okay, x and y, minimum is 1, maximum is 22, all right? 1 to 22, and the maximum of y is 100, all right? 100, not more than 100, not greater than 100. Okay, and then this is specified my line, okay, how the line will display. And then you draw the original scatter plot, and you draw the line of polynomial regression, okay, by calling plot. This is my line, okay, my line is here. You are going to draw here, and also my model is here, okay, my model. And then you display the diagram, okay. You see this is the polynomial line that represent the data points that fit to the data point. So it's curious to know our values, okay. It is important to know how well the relationship between the values of x and y axis is. If there are no relationship, okay, the same thing like the linear regression. If there are no relationship, the polynomial regression cannot be used to predict anything. Polynomial regression cannot be used to predict anything, okay. You have to compute R. Relationship is measured with a value called R square, not R, okay. R square values range from 0 to 1, where 0 means no relationship and 1 means 100% perfect related. And Python and scikit-learn, okay, another modules, okay, I'd like to mention about it later, scikit-learn. Okay, if you want to learn more about machine learning, scikit-learn module is very important, one of a very powerful modules. Okay, we'll compute this value for you. All you have to do is fed it with the x and y array. So we still have time. Look at import numpy from scikit-learn metric, import R2 score. Because we are going to compute R square, R2 is R square. Okay, we feed x and y into the model. Okay, polyfit, the same thing, all right? Feed x and y into the model, and this is the degree, okay? This is the degree of fitting polynomials, okay? 3 is the degree of polynomial. Try through, you can try other values like 1, 2, and observe the change. So you can print R2 score. Okay, you need y and model here because you have a model. Okay, you put x, okay, each x starting from 1, 2, 3, 4, 5. Oh, I don't know, where's 4? To the model. Okay, and then you compute R square. Okay, R square is 0.94. Okay, the result 0.94. What does it mean? It shows that there is a very good relationship, and we can use, okay, polynomial regression in future prediction, okay, to confirm, okay, that can we use polynomial regression for the prediction, for predicting, or for future prediction. So we have to compute R square. Okay, and if you want to predict future values, okay, we can use the information you have gathered to predict future values. Okay, let us try, okay, to predict the speed of a car that passed the toll booth at around 5 p.m. Okay, to do so we need the same model array from the example above, you know, my model here. Use this, okay, and you can just import numpy, do the same thing, my model, polyfit, okay, with this. Okay, you call the model again, and x is 17. Okay, when you print the speed is y values. So the predicted y values, okay, of this polynomial regression is 88.87. Okay,